These are notes 19. Solve by graphing. The essential question, how do I solve systems of linear and quadratic equations? These notes will just cover solving by graphing. Your next notes will cover the other ways. This is section 12-10 in your book, page 802. The warm-up should be done. If not, copy it down, pause if you need to, and you will have to graph this piecewise function. So here is the beginning of the notes for today. I'm going to show the book also. This goes right along with the book. So copy this down and I'll explain it right now. So I'll show you page 802 in the book. This is the essential understanding. All right, it says you can solve quadratic and linear functions graphically and algebraically. You might remember in Math 1 that you would solve a system of linear equations. You learned how to solve by graphing, so you graph and see where the two lines intersect. You can solve by substitution, where you substitute one equation into the other equation and solve. And you can also solve by elimination method, where you cancel out a variable and solve for the remaining variable. So it's going to be pretty similar. So try to remember that prior knowledge that you learned from Math 1, how to solve by graphing, substitution, or elimination. You can have 2, 1, or no solutions. The solution, actually let me underline that, 2, 1, or no solutions. The solution is, or there might be more than one, so then the solutions are the ordered pairs where the line and parabola intersect. So there might be more than one solution, there could be two. So the solution is, or the solutions are, the ordered pair or ordered pairs. Remember those go x comma y for the ordered pairs. So again, it's where the line and parabola intersect. I'm going to show you right now page 802 for examples. If you're not done copying that down, then pause. Pause right now because I'm going to move it. All right, so this is page 802 in the book. This is showing the first graph is showing two solutions, so it would be those two. The second graph is showing if there's just one solution. And then this third graph shows no solution. So again, we're looking for where the line intersects the parabola. It's linear and quadratic. So you could have two solutions. Here we just have one, and here we have no solutions. And it's not the solutions like we've done before where we see where does it cross the x-axis. We're seeing where does the line and the quadratic, the parabola, where do they intersect. So that's in your book. All right. Okay, so let's go ahead and we're going to do two examples just so you can see. It would be nice if we had graph paper, but my notebook is lined paper. So I just thought you guys are probably using lined paper too. I'll use it as well. Just do your best to draw a straight y-axis. This one's your y, and straight across x. I counted by twos using the lines in the paper. And then I try to space it evenly over here. If that's 2, I try to space it as evenly as possible. All right, so get your graph all set up. And I'm going to start going over how to graph your two equations. So as you can see, this first one is quadratic. It would be a parabola. It's positive in front of the x squared, so I know that one's going to have a parabola U shape. This one is linear. It's got a negative slope, so I know it's going to go downward like that. We're going to do y equals mx plus b for the linear, and for the quadratic, we'll do an xy table. So do whichever one you want first when it's on your own. I'm just going to do the parabola first because it's first. It doesn't really matter to me which one's first. So remember to find the vertex. You have to start by doing your negative b over 2a. And remember, it should be in standard form. A is 2 here. There is no b, so it's 0. It would be your whatever x. It's 0x. And then my c value is 1. So if I do negative b over 2a, it would be negative 0 over 2 times 2, which is just 0. So my x value for the vertex is 0. So to find my vertex, it would be 0, and then I plug in 0, 0 squared is 0, 0 times 2 is 0, so it'd be 1. So that's how I know how to start off my xy table. Remember, parabolas have symmetry. So 0, when I plugged in 0, I just solved mentally because that was easy. Then, since it is symmetric, I can go 1, 2, and then I can copy the points over to -1 and to -2 because of that symmetry. So I'll show you and remind you guys as I graph it. I might even want to pick one more value. It might fit on the graph. So I'll show the work, but if you can do this mentally, do it mentally. Substitute in 1 for x. That would be 2 times 1 squared plus 1. 1 squared is 1. 1 times 2 is 2. 2 plus 1 is 3. Then I plug in 2 into this equation, the parabola one. 2 times 2 squared plus 1. 2 squared is 4. 4 times 2 is 8. Plus 1 is 9. That's going to start getting up pretty high. So I don't even think I need this value for 3. All right, so I'm going to go ahead and plot those points. I'm using pencil. I usually like to use pencil because if I make a mistake, I can just erase it. So I've got my points 0, 1. So x is 0, y is 1. I've got 1, x is 1, y is 3. But then, like I was saying, how there's symmetry, you want to copy that over. It would be symmetric across this one, the axis of symmetry. So I just have to count over 1 and then over 1. But I have to make sure I have it lined up right. Okay, and then I've got 2, 9. So I've got 2, x is 2, y is 9. I got to be careful. It's right there. And then same thing, it would be -2, 9 right there. Connect with a curve. And there we, oh, I missed it. There we go. Okay, so that's my parabola. And I have the XY table to look back at if I need to confirm the points that it is 2, 9, 1, 3. And like I was saying, I've got symmetry. It's -1 and 3 and -2, 9. And I thought that would be way too high. The number would be up above the graph. All right, so then to graph my linear, it would be, remember y equals mx plus b. M is your slope, it's -2 over 1. B is 5. Start at 5 right here. I'm going to trace it in color after, but I do want to just use pencil in case if I have to erase. Down 2, right 1, down 2. That seems like a point of intersection. Yeah, 1, 3. So there's going to be one point of intersection. I'm making it bold. And while I'm right here, I'm going to write what the ordered pair is. It's 1, 3. My x value is 1. My y value is 3. So 1, 3. I shouldn't draw an arrow. I'm just showing that that's what the coordinates of that point will be, 1, 3. And then I can continue my slope down to 1, 2, right 1. I could start from my y-intercept and do opposites, up to left 1, 1, 2, left 1. I want to see where it intersects exactly, so I'm being careful. 1, 2, left 1. So it's going to be this point as well. So I'm figuring it out as I didn't even draw my line yet, but as I'm counting my points, I can see the points of intersection where my line will cross through the parabola. So this point, it would be at, I think that was at -2 and 9. -2 for x, 9 for the y value. Then I can use my ruler. Whoops. I'll just move that and connect my points very, very carefully. The domain isn't restricted or constrained at all. So I don't have to like stop at a certain value. I just draw arrows on the ends of my line. I missed it a little bit. Since I didn't use graph paper, some of my points are off just a bit, but there, that's basically it. Okay, so there's my line and my parabola. So I've got my answers already. I'm just gonna use color to show the different functions a little bit better. Okay, there's that one, and the 2x squared plus 1 is the parabola. It just looks better. I like it better like this. Make sure you always have your arrows. The arrows mean that it's continuous and it keeps on going. Okay, so now I've got my two solutions. Since I was careful when I was counting my rise over run, I already know, and I wrote down the numbers or the solutions 1, 3, and then right here it was -2, 9. So I would just maybe write sentences or a sentence with the solutions. The solutions are -2, 9 and 1, 3. If you have a real life situation kind of a problem, sometimes our negative x values don't they don't count. So sometimes there's only one solution that makes sense. Like maybe our x values stand for time as time goes by. That like if it was a stopwatch timer thing, it would start at 0. Our negative value wouldn't count. So just be careful in the future. Like if it's a real world problem, sometimes our negative ones don't count. But this one, it is a solution. It counts. So we have two solutions. So just to review real quick what we did, identify what types of functions we have. It was quadratic. It was a parabola opening up. This one was linear. It had a negative slope. I knew it would point downward. That just kind of helps you plan out what it would look like. I graphed the parabola by finding the vertex first. It was my -b/2a. That gives me my x value. I plug it in and get my y, plug it into the equation. I did it mentally because plugging in 0 is pretty dang easy. Then from 0, I just counted up to get 2 more points and used symmetry. Once I plotted those points, I got the symmetric points on the other side of the axis of symmetry. They're just straight across. For the line, I did y equals mx plus b. You identify m and b, and you plot. Always start with your y-intercept. Do that first, and then you do your rise over run. So start at b, which was 5, and then I did my slope down 2, right 1, down 2, right 1, like that. Find the points where they intersect, and that's pretty much it. All right, so let's go ahead and move on to the next one. So again, today we're just focusing on solving by graphing. The next day of notes, we will solve algebraically, which means using elimination and substitution. Okay, if you needed to get that, pause the video. Also, you can start writing down number 2. So our second example, this is from the book too. If you want extra practice, you can look at the problems in the book. So I've got y equals x squared plus 2x plus 5 and y equals -2x plus 1. And I did a graph really similar. I checked ahead on Desmos.com to see what numbers I need to show, because I'm sure you guys have graphed before and you're like, oh, I didn't draw my graph big enough, or like the solution's way over here, and you have to like adjust it. So I made sure that this would be a big enough graph to show the solutions. Okay, so let's focus on number 2 now. So just like number 1, I want to, it doesn't matter where you start. I'm just going to start with this one. I'm going to analyze it. It's a parabola because it has an x squared. It's positive. It opens up. I'm just kind of planning. I want to do my -b/2a to get my vertex value. So negative, I'm just going to identify b is 2. My a is, there's nothing, so it's a 1. So it's -2/2 times 1. That comes out to -2/2 or -1. So when I draw my xy table for the quadratic, I want to start at -1 and then count up 1 to 0 and count up 1 more to 1. And then I'll use symmetry to get my other points going backwards from -1, -2, and -3. All right, continuing with my plan, I see this is a negative linear equation. It should go down from left to right. I know that because of the negative in front of the x. My m is -2/1, and my b is 1. I'll do that second. Okay, so now I've kind of planned it out and I'm going to have a parabola going up. I have a line going down from left to right. It might intersect in two places like the last one. It might intersect in just one, or it might not intersect at all. If they don't cross, you put no solution. All right, so here I go. I'm going to start substituting in my values. I'm plugging it into x squared plus 2x plus 5. So negative 1 squared plus 2 times negative 1 plus 5. I'm going to solve it mentally. I don't want to like have too much work. So negative 1 squared is 1. That's negative 2. 1 plus negative 2 is negative 1. Negative 1 plus 5 is 4. Then I plug in 0. 0 squared plus 2 times 0 plus 5. Again, I'm plugging into this equation in for x. 0 plus 5 is 5. Then I plug in 1. 1 squared plus 2 times 1 plus 5. 1 squared is 1, plus 2 times 1 is 2. So 1 plus 2 is 3. 3 plus 5 is 8. I could show it on the table if I wanted to, but I'm just going to get my other points using symmetry. But you can, like I did up here, you can always show them in the table too. It would be a 5 and an 8 for negative 2 and negative 3. So here I go. I'm just going to go ahead and plot these points. Again, be super careful. This matters. This is how we get our solution. X is negative 1, y is 4. Right there. Okay, 0, 5, so 0 up to the 5. But then I use symmetry across the axis of symmetry. I go over 1. That would be at negative 2. Again, you have to be really careful when you make your graph. Graph paper is always nicer. Okay, and then I've got 1, 8. So I go to x is 1 all the way up to y is 8. About right there. And then I use my axis of symmetry across where the vertex is. So that'd be 1, 1, 2, and then 1, 2. So this point is negative 2, 8. Negative 2, 8 right there. That's enough points for me to draw the parabola. Again, it's important that you know what the actual values are here. I know that it's negative 2, 8, and this one's 1, 8. Because any one of these might be my solution. Remember that a parabola is curved, it's not pointy, so you want to curve it. There, it's the U-shaped graph. Okay, so I've got that one. Once I'm sure I'm done, that's when I'm going to add color. I don't want to add color yet because I might have to erase something. For my linear equation, I start at 1, put a point, and then I do my slope. It's negative 2 over 1, so down to right 1. That's kind of going in the wrong direction. Everything happening is up here. So instead of negative 2 over 1 down to right 1, I can do 2 over negative 1 up 2 left 1. So you can always, it'll still be in the same direction. It'll be like this. It's a negative slope. I know it's going to have this kind of shape. So from 1, I count up to right 1. That doesn't intersect yet. But now when I count up 1, 2, left 1, that is going to be a point of intersection. I'm just going to use my ruler and trace the points. That would have been down to 1, 2, right 1. That's right there. Okay, so about like that. Again, I didn't use graph paper, so it's not like perfect, but I can see what's going on. This is what one solution looks like. You're going to get this in your Math Excel homework quite a bit. The one solution is right here, this point. It's at negative 2, 5. I'm going to write it right here, negative 2, comma 5. One solution. It only intersects, the line only intersects at one place. So I've got my line right here in blue. There. That's my negative 2x plus 1. And then I've got my parabola, I'll do in pink. It's my x squared plus 2x plus 5. It's this one. And again, it only intersects in one place. It's kind of hard to see, but it is exactly at that point. They both share that point. It kind of looks like it touches the side of it, but it really doesn't. Like if you had Desmos, you could zoom in at that one point and see that it is really just right there. It's not touching anywhere else. So I can write my answer. The solution is -2, 5. All right, good luck on your homework. Remember how to do piecewise from the warm-up. There's a little bit of that on Math Excel. And then solving linear and quadratic functions by graphing. You want to look for the points of intersection. Remember to do your questions and your summaries on the notes as well.